In this video we're continuing with the topic of vectors and we're going to concentrate on perpendicular vectors. So firstly, a task. I would like you to find the dot product of vectors A and B given this diagram. So if you pause the video just now and give this a wee try and then come back and we'll go over the answer. Okay, welcome back folks. So hopefully you managed that okay. If not, we're going to go over it just now. So remember the dot product, given that we've got an angle, we would look at the polar perspective of the dot product. So that's the magnitude of A multiplied by the magnitude of B multiplied by cos theta, where theta is the angle between vectors A and B. So we don't have any information about vectors A and B, so we'll just keep it in the general form, the magnitude of A times the magnitude of B multiplied by cos of 90. And you can see that there is a right angle between A and B, and that's why it's cos 90. Now, cos 90, we should know the exact value from that from the cosine graph here. So there's cos 90, and you can see that that is 0. So it's the magnitude of A multiplied by the magnitude of B multiplied by 0, which gives us the dot product of A and B to be 0. So if A and B are perpendicular, it means that A dot B is equal to 0. And conversely, if A dot B is equal to 0, then A and B are perpendicular. So this is an important property that you should remember. And if you do forget it though, and you remember the formula for the dot product, and you have the angle between the two vectors, then you should be able to calculate that A dot B is equal to 0. So let's look at some examples where you might need to use the properties of perpendicular vectors. So example 1, two vectors are defined as A equals 4i plus 2j minus 5k and B equals 2i plus j plus 2k, and we want to show that A and B are perpendicular. So we know for perpendicular vectors that we're looking to find A dot B to be equal to 0. Now, we've been given these vectors, A and B, and they are written using the unit-base vectors I, j and k. So we can use the rectangular perspective of the dot product. So A dot B is equal to 4 multiplied by 2 plus 2 multiplied by 1 plus negative 5 multiplied by 2. That gives us 8 plus 2 plus negative 10. And we can see there that our dot product A dot B is equal to 0. We need our communication then. So since A dot B equals 0, A and B are perpendicular as required. So just now it would be a good time to pause the video and take this example down in your notes and then come back for example 2. Okay, welcome back folks. So we'll have a look at example 2 now. And this time we're told that vector PQ is equal to 4a, 7, and vector RS is equal to 2, negative 3a, where a is a constant. Given that PQ and RS are perpendicular, find the value of A. So we're already told that PQ and RS are perpendicular, so that means that the dot product of those two vectors must be equal to 0. Again, we'll look at this, look at the dot product using a rectangular perspective, and we need to remember all the time that this is equal to 0 because we know that these vectors are perpendicular. So we've got 4 multiplied by 2 plus A multiplied by negative 3 plus 7 times A is equal to 0. And evaluating those products, we get 8 plus negative 3a plus 7a equals 0. That gives us 8 plus 4a, and we can then subtract our 8 from both sides and divide throughout by 4. And that obtains a equals negative 2. And that means that when a is negative 2 in here, PQ would be 4, negative 2, 7, RS would be 2, negative 3, negative 2, and that would, we can see then that they would be perpendicular. So just now it would be a good time to pause the video before the screen goes blank, take this down in your notes, and then complete the assigned questions for today.